Hello everyone. So let's start our journey to learn System Verilog for design and verification. So this is our agenda for this session. So here we will understand what, why and how of System Verilog and its history. Then we will create small example, the Hello World example, which is probably the first program you write in every language. Then we will see how to compile it and simulate it. So basically, when you will write programs using both Verilog and System Verilog, then you will understand how System Verilog eases the development of your design or basically test benches. So what is System Verilog? So it is basically an extension to Verilog. Verilog and VHDL, they both are hardware description languages, but they were lacking verification features. So what that means is creating and maintaining test benches using these hardware description languages, that was very difficult because they were lacking lot of features which is required for writing big test benches. For example, it does not have oops concepts. And there are many other features which are needed for writing big test benches. So earlier test benches were written using HDL languages, that is Verilog and VHDL. But it was very difficult to maintain and reuse these kind of test benches. So that is why HVL, that is hardware verification language, came into picture. So System Verilog is both HDL and HVL. Means it can be used to create designs also, and it can be used for verification also. So basically it is a combination of both HDL and HVL. So now why do we need System Verilog? So what was the need? So as we already discussed, this HDL languages, hardware description languages, they were lacking the verification features. So that is why each EDA vendor ended up in creating its own solution for that. Like we had eSpecman from Cadence, we had Vera from Synopsys, and System C, that is mostly kind of C. And it was also used for verification. But one of the biggest problem with these custom solutions from each EDA vendor was the portability of the platform. For example, say I spent years in creating a big test bench for my duty. Now porting that test bench to another EDA vendor, that was almost impossible. Why? Because Synopsys will not support eSpecman and Cadence will not support Vera. And even if they support, that would be very basic or very weak support. It might have bugs. So all the big companies, whoever making the chips like Intel, Apple, they wanted the languages to be EDA vendor independent so that they can run their platform on different EDA vendors. So it's very common that a single project in one company, a single project is using two different tools for different flows. They might be using Cadence tool also, and they might be using Synopsys tool also. So the portability and the reusability, that was the big issue. So that is the why there was a very strong need for creating a standard for hardware verification language. And that is where IEEE committee came into picture. So I think in 2004 or in 2005, they came with the SV standard. So their main goal was to improve productivity, readability, and reusability of the Verilog code. So basically it enhances Verilog with these directed and constrained random test bench development, object-oriented programming concepts, then coverage-driven verification, assertion-based verification, and many more features. So now every EDA tool, every EDA vendor supports System Verilog. So if you write your test bench in one language, it can run on any simulator. So it is a very high level view just to show what all have been added in System Verilog. So earlier for very long time, we had Verilog 95. So it had all these constructs which are specified here. Later, Verilog specification got improved, which we used to call Verilog 2K in 2001. So it added some of other constructs which helped in faster development and eases out the job of designer or verification engineer. After that, in 2004 or in 2005, we had system Verilog specification. And some of the EDA vendor already started supporting these constructs by the time the formal LRM was out. So it was basically an extension to Verilog, and it supports lot of new features like we have classes, we have inheritance, we have program blocks, we have clocking domains, we have assertions, and many more features. So let's go through some of the system Verilog features. Firstly, it extends the data types. We will come to data type later when we discuss it in detail. Then it adds more operators for concise description. Then it adds more procedural statements like final blocks. System Verilog enhances process control. Then task and functions also got improved. You can use pass by reference feature, which was not there in Verilog. A big feature that was added in System Verilog is classes and OOPS concepts. Basically, these concepts allow abstraction and encapsulation, and then randomization. Then scheduling semantics also got enhanced because of these new constructs. Then inter-process communication constructs also got added in System Verilog, like mailbox, semaphores, and events. It also supports clocking block, assertions, package and compilation units, interfaces, functional coverage, and DPI. Basically, it adds lots of new features which you need for verification. Now, not only for verification, but it also enhances the design constructs like always underscore comp and always underscore ff. With the help of these constructs, you can specify the intent you are trying to implement, whether you want to implement the combinational block or sequential. In Verilog, we could make a mistake while writing the code and it might get wrongly synthesized. So let's get started. First program we write in any language is Hello World program. So write a small Hello World program and try to simulate and run it. So here in this program, in the initial block, I have written this $display statement, which displays the Hello World. So this is very similar to Verilog, right? But in Verilog, we do not have the program construct. In Verilog, we use module. So in System Verilog also you can use module. I have just used the program to distinguish between Verilog and System Verilog. And what exactly is the program block that I will cover later. So for now, just try to compile this program by setting your environment. Now let's understand how to compile our first Hello World program. See, Verilog simulators are available as free tools like iVerilog and Seaver. But system Verilog compilers are not really free like Verilog. So some of the most commonly used commercial simulators in the semiconductor industry are VCS, it's a Synopsys tool, Synopsys VCS, then Mentor, Siemens, Questasim, then Cadence, Xcelium. These tools are used by almost every semiconductor company for design verification and simulation. If you don't have access to this commercial tools, then you can go and use the EDA Playground. This is an online website. You can go and register there and try to run your program. So it has support for all simulators like VCS, Questasim, Xcelium, and so you can directly use them. So the first command to compile your program is VCS -s verilog hello.sv. So here VCS, it launches the Synopsys compiler. This -s Verilog, this is option. It tells the compiler that our source file is written in system Verilog. And hello.sv is our source file name. So when this command executes, then VCS compiles the code and generates an executable simulation file that is called simv. Now to run this simulation file, we simply execute this command /simv. So when you run this, then simulator runs our design, executes any initial blocks or test bench code, and displays the output on the terminal. So the overall flow is very simple. First, you have to write the code, then compile it, then run the simulation and observe the output. So this is the basic workflow that we will follow throughout this course, whether we are writing simple examples or complete verification environments.
Thank you for attending this lecture. If you have any queries, doubts, or need further clarification, please put them in the Q&A section, or you can leave your comments under this video. Thank you.